And now a word about programming. I've chosen to teach this course in Python. It has built-in sets, lists, and dictionaries, data structures that make it particularly well suited to the somewhat idiosyncratic approach I take to implementing vectors and matrices. If you've worked with Python before, you are probably acquainted with Python's use of these data structures. However, my favorite feature of Python is one that even Python programmers might not be so familiar with: the comprehension. A comprehension is an expression that produces a set, a list, or a dictionary. It's very concise, but also easy to read, as long as you're used to it. A comprehension gets you some of the power of functional programming, but are accessible even to those who think lambda is some kind of risque dance. A comprehension syntactically resembles the notation used by mathematicians to write down sets. Perhaps most important for our purposes, a comprehension allows you to write a procedure with only a single line without sacrificing readability. This is important because in many of the quizzes, we ask you to write a single line procedure. Your answer to the quiz is matched against patterns that we've prepared. That means that in order for your quiz answer to be judged correct, you have to write it the way we have in mind. Another reason you need to understand comprehensions is that I use them in the code that I write and show you. Finally, if you've mastered comprehensions, your Python code will be more concise and more readable. Okay, as you can probably tell, I'm a little obsessed with comprehensions. Anyway, we'll teach you the part of Python that you need to know for the course. The first lab assignment will go through sets, lists, dictionaries, and comprehensions for all these things. Even if you already know Python, you should really skim through that first assignment to review the features of Python that we use and to learn my terminology for them. The second lab assignment is intended to give you more practice in programming with Python. These two assignments don't depend at all on the lectures, and you can start them right away. Also, they don't count that much towards your grade, so don't worry over much about your performance on these assignments. My main bit of advice: try stuff out. My intention is that you be empowered to work with vectors and matrices and the algorithms that operate on them. Bring it home. Give these concepts substance. Don't be content to just watch some videos. Whether on paper or with the computer, you need to work with the concepts we're developing in order to gain understanding. That's where the real learning takes place, not when you're listening to me drone on. I can't emphasize this enough. If you don't understand something, or even if you do, try it out. In the video lectures, I'll show you my working with Python. This isn't just for show. This is how I've managed to learn the concepts, by trying things out with Python. In this course, I don't assign a lot of drills. Many linear algebra courses do involve a lot of drills, and there's actually a good reason for that. You need a lot of practice. My favorite scene in the movie, The Matrix, is when Morpheus straps Neo into a chair and inserts what looks like a 70s era video cassette into a machine and streams into Neo the knowledge of how to fight. In a few minutes, he's an expert. I wish I could strap my students into chairs and teach them that way, but the brain doesn't work that way. The input device is not what's limiting. You need to practice. I'm giving you the tools, but you have to take the initiative. I trust that you can find lots of examples and drills out there on the web or in the many books on this subject. My second bit of advice is, unfortunately, you're going to have to do a little bit of memorization. There are a lot of concepts and definitions, and you need to keep them straight. In particular, in the early part of the course, we'll discuss different interpretations of matrix vector, vector matrix, and matrix matrix multiplication. You need to really learn these interpretations in order to even understand the lectures that come afterwards. Now a word about proofs. Mathematical statements, lemmas, propositions, theorems are an essential part of linear algebra. They underlie the concepts that we use. Since it's easy to be fooled by your intuition, we need mathematical proofs to convince us that these statements are true. In this course, I present proofs for most of the theorems relevant to the topics we discuss. Due to limitations of massive online courses, I'm not going to require you to produce mathematical proofs. If you don't consider yourself mathematically inclined, you might be tempted to just skip the proofs. That would be a mistake. Mathematical proofs are not there just to convince, but to provide insight. The best kind of proof helps us understand why a theorem is true. Working through the proof, trying to understand its steps, helps us understand the meaning of the theorem and also helps us learn the theorem. Since I'm a coder, I tend to think of things algorithmically or procedurally. So I've chosen proofs that lend themselves to that kind of thinking, procedural or algorithmic proofs. Sometimes I'll ask you to code a procedure that follows the structure of the proof. The resulting procedure is not generally the most practical way to solve the problem, but it will help you gain insight into the proof. This will help you learn the proof. It doesn't necessarily give you the best way to solve the problem. And now a disclaimer. I'm not trying to train you to develop the next linear algebra library. For one thing, that would require a deep knowledge of numerical analysis, which is, at least in part, the ability of numerical algorithms to tolerate round-off error. You won't always learn the most efficient or most accurate way to solve a problem. The methods I teach are a compromise between, on the one hand, efficiency and accuracy, and on the other hand, pedagogical value. Now a word about the assignments. There are 3 kinds of assignments each week. First, quizzes. Quizzes are given in the videos or right after the videos, and they're there to reinforce the material. Your performance on quizzes doesn't enter into your grade, but you will be expected to know and understand the answers to all the quizzes. And in fact, some of the later programming assignments build on those answers. Another word about quizzes. We use pattern matching to judge your answer right or wrong. If your particular solution doesn't match the pattern, it'll be judged wrong. I know how frustrating it is to be told your answer is wrong when you are pretty sure that it's a correct answer. We plan to provide a button for you to click on when you're sure your answer is right. Now, we won't get back to you about the answer, but we'll use this feedback to improve the course for the next time. A big chunk of the work you do each week is the homework assignment. A homework assignment is just a collection of problems. Some of those problems we won't ask you to submit. They're there only to help you learn. Others, both numerical problems and programming problems, we'll ask you to submit, and we'll explain the submission process to you. Finally, labs. A lab is like a homework assignment. It's a collection of tasks that you're supposed to carry out, but all these tasks are oriented towards one goal. It's in the labs that you'll see some of the fun applications of linear algebra. I've written a textbook that students use in the Brown version of this course. It covers everything, including the advanced topics we won't get to in this 8-week course. It's absolutely not necessary for this online course. We'll present everything you need in the video lectures and in materials that accompany them. But for those students who feel the need for a written record of the material and topics covered in the course, I'll link to it from their webpage. The course is difficult. It's going to take a lot of work on your part, but you're not alone. There's the forum where you'll be able to post questions and get help from your colleagues who are also taking the course. Let's get to it.